The turbine blade shouldn't have worked. Everyone at Power Jets Limited knew it. The chief engineer said it was rubbish. The metallurgist declared it scrap metal. But when Frank Whittle fired up the prototype on that cold January morning in 1941, the salvage blade that Edward Clarke had spent 3 months filing by hand in his cramped garden shed held firm. It didn't just hold, it sang. The numbers on the pressure gauge climbed higher than they ever had before, and in that moment, a single-father machinist who earned £7 a week had just changed the course of aviation history. The question that haunted everyone afterwards was simple. How did a man with no formal engineering degree, working with materials everyone else had thrown away, manage to solve a problem that had stumped Britain's finest minds for 2 years? Before we carry on, please hit the subscribe button to make my day and let me know where you are watching from in the comments. Edward Clarke never planned to become part of history. In the autumn of 1939, when Britain declared war on Germany, he was 32 years old, a widower raising his 8-year-old daughter Margaret in a 2-bedroom terraced house in Lutterworth, Leicestershire. His wife Anne had died 3 years earlier from tuberculosis, leaving him to navigate fatherhood alone while working 60-hour weeks at the local machine works. The pay was modest, barely enough to cover rent and food, but Ned, as everyone called him, had something more valuable than money. He had hands that could feel imperfections in metal that measuring instruments couldn't detect, and a mind that refused to accept that anything was truly worthless. The machine shop where Ned worked wasn't glamorous. It was a dark, oil-stained building where the air tasted of metal shavings and burnt lubricant. The floor vibrated constantly from the lathes and milling machines, and the noise was so overwhelming that most men lost significant hearing by the time they reached 40. Ned had worked there since he was 16, starting as an apprentice sweeping floors and slowly working his way up to master machinist. His specialty was precision work, the kind of jobs that required tolerances measured in thousandths of an inch. While other machinists rushed through their work to meet quotas, Ned took his time, checking and rechecking every measurement. His supervisor, a thick-necked man named Gordon Wells, constantly berated him for being too slow, too meticulous, too perfectionist. But the clients knew better. When they needed something done right, they asked for Clarke. The war changed everything about life in Lutterworth. Suddenly, the quiet market town found itself home to a mysterious new company called Power Jets Limited, which had leased an old foundry on the outskirts of town. Rumors spread quickly through the local pubs. Some said they were building a new type of bomb. Others whispered about rocket ships. A few insisted it was all an elaborate ruse to confuse German spies. The truth was more extraordinary than any of the rumors, but very few people knew it. Power Jets was attempting to build the world's first jet engine, a revolutionary propulsion system that would make propellers obsolete. Leading the effort was a young RAF officer named Frank Whittle, whose radical ideas had been dismissed by the Air Ministry for years before the war finally convinced them to give him a chance. Ned first heard about Power Jets in December of 1939, when Gordon Wells gathered the machinists together during their lunch break. Wells announced that Power Jets needed subcontractors for some specialized work, and that several men from their shop would be sent over to help. The job paid an extra 2 shillings a week, which was enough to make every man in the room sit up straighter. Wells read from a list, calling out names, and Ned's heart sank when his wasn't among them. The chosen men were younger, faster workers who could produce parts quickly. Ned's meticulous approach wasn't needed for rush work. That evening, Ned walked home through streets darkened by blackout regulations, his hands shoved deep in his coat pockets against the December cold. Margaret was waiting for him at the kitchen table, her schoolbook spread out before her, struggling with arithmetic. She had Anne's dark hair and serious eyes, and sometimes when Ned looked at her, the resemblance was so strong it physically hurt. He helped her with the math problems, explaining fractions using slices of their rationed bread as visual aids, then made them both a simple dinner of boiled potatoes and the last of their week's meat ration. After Margaret went to bed, Ned sat at the kitchen table and calculated their finances. The numbers were grim. Margaret needed new shoes, their roof had developed a leak, and winter coal was becoming increasingly expensive. That extra 2 shillings a week would have made a real difference. The following Saturday, Ned made his weekly trip to Humphrey's scrapyard on the edge of town. It was a habit he'd developed years ago, hunting through discarded metal for materials he could use in his hobby work. Ned spent his evenings in a small shed behind his house, working on various projects, fixing broken tools for neighbors, fabricating replacement parts for old machinery that couldn't be replaced due to wartime shortages. He charged only what people could afford, sometimes nothing at all for families he knew were struggling. The work kept his hands busy and his mind occupied, helping him avoid dwelling on Anne's absence. Cyril Humphrey, who ran the scrapyard, was a barrel-shaped man in his 60s with permanently grease-stained hands and an encyclopedic knowledge of every piece of metal in his yard. He and Ned had developed a friendship over the years, built on their shared appreciation for materials most people considered junk. This particular Saturday, Cyril waved Ned over with unusual excitement. He had something special to show him. In the back corner of the yard, covered by a tattered tarpaulin, sat several wooden crates stamped with the Power Jets company marking. Cyril explained in a low voice that the crates had been delivered by mistake to a regular client who did fabrication work for the railway, and when the mix-up was discovered, Power Jets had told them to just scrap the contents rather than deal with the paperwork of returning them. The crates contained turbine blades, dozens of them, all rejected from Power Jet's production line. Cyril pulled one out and handed it to Ned. The blade was about 8 inches long, elegantly curved, made from a nickel alloy that felt substantial in Ned's palm. He could immediately see why it had been rejected. There was a stress fracture running along one edge, microscopic but definitely there, plus several areas where the metal showed signs of improper heat treatment. Ned's mind immediately started working through possibilities. The blade was damaged, yes, but perhaps not beyond salvation. If the fracture could be ground out, if the heat treatment issues could be compensated for through careful reshaping, if the tolerances could be brought back to acceptable levels through patient, precise work, then maybe these worthless scraps could become useful again. He asked Cyril what he wanted for the entire lot. Cyril laughed and said if Ned could haul them away, he could have them for free. The space they occupied was worth more than the metal itself. Ned borrowed a handcart and spent the rest of the morning transporting the crates to his shed. Margaret helped, clearly curious about why her father was so excited about what looked like useless scrap metal. He tried to explain that sometimes the difference between worthless and valuable was just a matter of perspective and effort, but she just rolled her eyes in the way 8-year-olds do when their parents try to impart wisdom. That evening, after Margaret was asleep, Ned spread the turbine blades across his workbench and began his examination. Under the bright light of his work lamp, the blades revealed their secrets. There were 47 of them in total, no two exactly alike. Some had obvious flaws, deep gouges, or severe warping that made them genuinely unsalvageable. But others, maybe half the total, had problems that Ned thought he could address. The fractures could be carefully ground out if he was willing to reduce the blade's overall dimensions slightly. The heat treatment issues could be partially corrected by carefully annealing the metal in his small furnace. The dimensional inaccuracies could be fixed through patient hand filing and polishing. It would take time, hundreds of hours of work, but Ned had time. His evenings were his own, and sleep had been difficult since Anne died anyway. He started that very night, selecting the blade that seemed most promising and securing it in his bench vise. Using a jeweler's loupe, he mapped out every imperfection, marking them with a grease pencil. Then he began the slow, meditative process of filing away the damaged material. The work required complete concentration. Too much pressure, and he might introduce new stress points. Too little, and he'd never remove enough material. The file needed to move in long, even strokes, always following the grain of the metal, always maintaining the blade's aerodynamic curve. Within an hour, his shoulders ached and his eyes burned from the close work. He worked until past midnight, then carefully wrapped the blade in an oily cloth and went to bed. This became his routine. After putting Margaret to bed each night, Ned would retreat to his shed and work on the turbine blades. Sometimes he filed, sometimes he used fine abrasive papers to polish surfaces. Sometimes he carefully heated blades in his furnace to relieve internal stresses. He developed techniques through experimentation, learning from his failures. Some blades cracked beyond repair when he tried to anneal them, teaching him to use lower temperatures and slower heating cycles. Some lost their aerodynamic properties when he filed too aggressively, teaching him patience and restraint. Slowly, blade by blade, his pile of salvageable pieces grew. December turned to January, January to February. The war news was grim. The Luftwaffe was bombing British cities, and rationing grew stricter. Ned's daily life became a careful balance of work at the machine shop, caring for Margaret, managing their meager household, and spending every spare hour in his shed with the turbine blades. His neighbors thought he was slightly mad, wasting precious coal to heat his shed so he could fiddle with scrap metal. Gordon Wells heard about Ned's hobby and made jokes at the machine shop about men who needed better hobbies than playing with rubbish. Ned ignored the mockery. The work itself was reward enough. By early March, Ned had successfully reconditioned 23 turbine blades. They weren't perfect, he knew that. His measurements showed they were slightly undersized compared to what he assumed were the original specifications, and the surface finish wasn't quite as mirror smooth as factory-new blades. But they were straight, balanced, and free from any cracks or stress points his tools could detect. More importantly, each blade now fell within what Ned believed were acceptable tolerances. He had no way to test them under actual operating conditions, but he had faith in his work. The question now was what to do with them. The sensible thing would be to add them to his stock of useful materials and perhaps incorporate them into future projects. But Ned kept thinking about the men from his shop who were working at Power Jets, earning those extra 2 shillings, contributing to what everyone said was vital war work. These blades had come from Power Jets. They'd been created for a purpose, even if they'd failed to meet that purpose the first time. Didn't they deserve a chance to fulfill their original destiny? On a Friday afternoon in mid-March, Ned asked Gordon Wells if he could get an introduction to someone at Power Jets. Wells looked at him as if he'd suggested flying to the moon. Why would Power Jets want to talk to a slow-poke machinist who couldn't even get selected for their subcontracting work? Ned explained about the blades, how he'd reconditioned them, how he thought they might be useful. Wells' laughter echoed through the machine shop. He told Ned that Power Jets was working with the finest metallurgists and engineers in Britain. They had access to the best materials and equipment money could buy. They weren't going to be interested in some hobbyist's workshop scraps. But Wells, perhaps taking pity on Ned, or perhaps just wanting to teach him a lesson about knowing one's place, said he'd mention it to his contact at Power Jets. He warned Ned not to expect anything. A week later, Ned received a message to report to Power Jets the following Saturday morning. The note was curt and official, signed by someone named Robert Fenton, production supervisor. Ned spent Friday evening cleaning his best turbine blades with solvent and wrapping them carefully in soft cloth. He barely slept that night, alternating between excitement and dread. What if Wells was right? What if these fancy engineers took one look at his work and laughed him out of the building? Power Jet's facility was more impressive than Ned expected. The old foundry had been transformed with new equipment, and even from outside he could hear the roar of machinery being tested. A guard checked his credentials at the gate, and then he was escorted inside by a young clerk who led him through a maze of workshops and offices. The smell was familiar, hot metal and oil, but the intensity of activity was unlike anything at his regular machine shop. Men moved with purpose, hauling equipment, consulting drawings, shouting to be heard over the machinery. Robert Fenton turned out to be a thin, intense man in his 40s with prematurely gray hair and ink-stained fingers. His office was barely larger than a closet, packed with filing cabinets and technical drawings pinned haphazardly to the walls. He looked at Ned with obvious skepticism when the clerk showed him in. Fenton explained that Gordon Wells had mentioned something about reconditioned turbine blades, and while Fenton seriously doubted they would be of any use, the project was desperate enough that they couldn't afford to ignore any possibility, no matter how unlikely. He asked to see what Ned had brought. Ned unwrapped his blades on Fenton's desk, laying them out carefully. Fenton picked up the first one, holding it up to the light, squinting along its edge. His expression remained neutral, which Ned took as a good sign. If they were obviously terrible, surely Fenton would have said something immediately. Instead, the supervisor pulled out a micrometer and began taking measurements, consulting a specification sheet from one of his files. The minutes stretched out. Ned stood silently, his cap in his hands, waiting. Finally, Fenton set down the last blade and looked at Ned with an expression that mingled surprise and confusion. The dimensions were off, he said. These blades were consistently about 0.03 of an inch undersized. The surface finish wasn't quite to specification either, but, and he emphasized this word, they were remarkably consistent with each other. The work showed extraordinary precision, and, most surprisingly, they appeared to be completely free of stress fractures. How had Ned accomplished this? These were the same batches that their metallurgist had condemned as unsalvageable months ago. Ned explained his process: the careful grinding to remove cracked material, the annealing to relieve stresses, the patient hand filing to restore proper dimensions and aerodynamic profiles. Fenton listened with growing interest, occasionally interrupting to ask technical questions. How had Ned known what temperatures to use for annealing? How had he maintained dimensional accuracy without proper measuring equipment? What made him think these blades were worth saving in the first place? To the first question, Ned admitted he'd experimented until he found temperatures that worked, measuring success by how the metal behaved rather than by following any scientific formula. To the second, he explained that his regular work required extreme precision, and he'd learned to use feel and simple tools to achieve accuracy that rivaled more expensive equipment. To the third question, Ned said simply that he'd never believed anything was truly worthless if someone was willing to invest enough effort into it. Metal had value, skill had value, time had value. It seemed wasteful to throw away something that could be saved. Fenton drummed his fingers on his desk, clearly thinking. He told Ned that Power Jets was facing a critical shortage of turbine blades. Their current supplier couldn't keep up with demand, and their own machine shop was backlogged for months. The Whittle engine design required dozens of precisely manufactured blades, and every test run damaged or destroyed several of them. The entire project was moving far too slowly because they couldn't get enough blades fast enough. If, and Fenton stressed this was a significant if, these reconditioned blades proved usable, they could accelerate the testing schedule considerably. He asked Ned how many more blades he had. Ned said these 23 were the best of the batch, but he had another dozen or so that he thought could be brought up to similar standards with more work. Fenton nodded slowly, then made a decision. He would have Power Jet's metallurgist examine Ned's blades. If they passed inspection, Power Jets would pay Ned for them. Not much, but something. More importantly, if they passed inspection and proved functional in testing, Fenton would see about getting Ned some official subcontracting work. Real work, not just salvaging scraps, but actual manufacturing of new blades. Was Ned interested? Ned's heart hammered in his chest, but he kept his voice steady. Yes, he was interested. Fenton told him to come back in 1 week, same time, and they'd know more. Ned gathered his blades, now official property of Power Jets, and left the facility in a daze. On the long walk home, his mind spun with possibilities. If this worked, if his blades proved useful, it could mean better pay, more interesting work, a chance to contribute meaningfully to the war effort. It could mean Margaret getting those new shoes, maybe even saving enough to fix the roof properly before next winter. The following week crawled by. Ned found it hard to concentrate at his regular work, earning another lecture from Gordon Wells about daydreaming. He forced himself to maintain his routine, working on the remaining turbine blades each evening, even though he had no guarantee Power Jets would want them. Margaret noticed his distraction and asked if something was wrong. He told her something might be right, actually, but he didn't want to say more until he knew for certain. Saturday morning arrived. Ned returned to Power Jets, his stomach tight with anticipation. The same clerk escorted him to Fenton's office, but this time another man was there as well, a younger fellow with wild hair and intense eyes who was leaning over Fenton's desk, examining technical drawings. Fenton introduced him as Frank Whittle, the chief engineer. Ned recognized the name from the company letterhead, but hadn't expected to meet the man himself. Whittle looked up from his drawings and studied Ned with undisguised curiosity. He asked Ned directly if he understood what these turbine blades were for. Ned admitted he had no idea. Whittle's face broke into a surprising grin. He explained, in terms simplified for a layman, that he was developing a new type of engine that used turbines to compress air, mixed it with fuel, and created thrust through the exhaust gases. It was called a jet engine, and it would eventually make propeller-driven aircraft obsolete. But the technology was fiendishly difficult, requiring materials that could withstand extreme temperatures and pressures. The turbine blades were critical components. They spun at thousands of revolutions per minute in conditions that would destroy ordinary metal. Whittle told Ned that the metallurgist had examined his reconditioned blades and declared them remarkably good, surprisingly so for hand-worked pieces. The dimensional variations were within acceptable limits for test applications, and more importantly, the stress relief work was exceptional. The metallurgist couldn't explain how Ned had achieved it without proper equipment, but the results spoke for themselves. Whittle had decided to test one of Ned's blades in the next engine run, which was scheduled for the following Tuesday. Ned felt a rush of pride followed immediately by terror. What if the blade failed? What if his work wasn't actually good enough, and it shattered under stress, possibly damaging other components or setting back their testing schedule? Whittle must have seen the concern on his face because he laughed and said, "Failure was always possible. They expected failures, that's why they tested. Every failure taught them something valuable." But Whittle had a good feeling about these blades. There was something about work done by someone who genuinely cared about the craft that often outperformed work done purely by specification. The meeting ended with Fenton explaining that regardless of Tuesday's test results, Power Jets wanted to contract with Ned for additional blade reconditioning work. They had more rejected batches, hundreds of pieces that might be salvageable with the right approach. The pay would be 5 shillings per acceptable blade, which was far more than Ned had dared hope. Fenton gave him paperwork to fill out, forms that seemed endless, and told him to report back on Wednesday to learn the test results and pick up his first official batch of work. Tuesday evening, Ned couldn't focus on anything. He tried to help Margaret with her homework, but kept losing his train of thought. He attempted to work on his remaining blades, but found his hands shaking too much for the fine detail work. Finally, he just sat at his kitchen table, drinking tea and watching the clock, imagining all the ways the test might go wrong. At some point, Margaret came and sat beside him, leaning her head against his shoulder in a gesture of wordless support that made his eyes sting. Wednesday morning felt like walking to an execution. Ned arrived at Power Jets to find unusual activity. Men moving quickly with expressions of barely contained excitement. The clerk who met him at the gate was grinning. He told Ned that word had spread about yesterday's test. Everyone was talking about it, and he should go straight to Fenton's office. Ned's stomach dropped, preparing for bad news, but the clerk's smile didn't match that interpretation. Fenton's office was crowded. Whittle was there, along with several other men Ned didn't recognize, engineers and technicians based on their appearance. When Ned entered, Whittle actually stood up and crossed the room to shake his hand. The test had exceeded all expectations. Ned's blade had not only held under operating conditions, it had performed marginally better than their current supplier's blades, showing less vibration and more consistent pressure characteristics. The metallurgist theorized that Ned's hand finishing had created microscopic surface properties that reduced air resistance. Whatever the reason, the blade had been a complete success. Whittle explained that they'd now tested 4 of Ned's blades, and all 4 had performed admirably. The remaining blades would be incorporated into their next full assembly test, scheduled for later that month. But the implications went beyond just these salvage pieces. Whittle wanted to know if Ned would be interested in more substantial work. They needed someone who could manufacture blades in-house, working to specifications Whittle's team would provide, but using the same meticulous approach Ned had demonstrated. The work would require Ned to leave his current job and join Power Jets full-time. The pay would be £9 a week to start, with potential for increases as the project progressed. £9 a week. That was more than Ned had ever earned. That was security. That was Margaret's shoes and the roof repair, and perhaps even a little save for her future. But more than the money, it was the work itself. To be part of something genuinely important, something that might change the world, to use his skills on a project that mattered. Ned accepted on the spot. Gordon Wells was furious when Ned gave his notice, calling him ungrateful and predicting that he'd be back within a month begging for his old job. The other machinists were envious but tried to hide it, offering congratulations that rang hollow. Ned didn't care. His last day at the machine shop was the 1st of April, 1940, and he started at Power Jets the following Monday. The work was harder than anything Ned had done before. Whittle's specifications were demanding, requiring tolerances that pushed the limits of what was possible with manual machining. The materials were difficult, exotic alloys that behaved differently from the mild steels Ned was used to. The pace was intense, with constant pressure to produce more blades faster while maintaining absolute precision. Ned worked 12-hour days, often 6 days a week, coming home exhausted and covered in metal dust. But it was exhilarating. Every blade he completed brought them closer to a working jet engine. Over the following months, Ned became an integral part of the Power Jets team. His initial role of reconditioning salvaged blades expanded to manufacturing new ones, then to consulting on design modifications that would make blades easier to produce without sacrificing performance. Whittle began asking for Ned's input during engineering meetings, valuing his practical perspective that complemented the theoretical knowledge of the formally trained engineers. Ned taught other machinists his techniques, sharing the tricks he'd developed through years of experience and months of experimentation. The full assembly test in April was a watershed moment. The prototype engine, now incorporating dozens of Ned's blades, ran for a full 30 minutes at high power without failure. The sound was unlike anything anyone had heard, a continuous roar that shook the building and brought everyone in the facility running to watch. When Whittle finally shut it down and the noise died away, there was a moment of stunned silence before everyone erupted in cheers. Whittle found Ned in the crowd and pulled him forward, announcing that none of this would have been possible without the quiet machinist who had refused to accept that anything was worthless. Through 1940 and into 1941, the Whittle engine evolved from experimental prototype to viable technology. Each iteration brought new challenges, but also steady progress. Ned continued his work, constantly refining his techniques, training new workers as the project expanded. The original 23 salvage blades, the ones he'd reconditioned in his garden shed, became legendary within Power Jets. Whittle kept one in his office as a reminder that breakthrough innovations sometimes came from unexpected sources. Margaret noticed the change in her father. He was happier, more engaged with life, excited to talk about his work in ways he'd never been at the old machine shop. He had money for the first time since Anne died, enough that they could afford occasional luxuries, a trip to the cinema, a new dress for Margaret, fresh meat more than once a week. But more than the material improvements, Ned had found purpose. The shadow that had hung over him since Anne's death finally began to lift. In May of 1941, the Whittle engine powered an aircraft for the first time. The Gloucester E-28/39 took off from RAF Cranwell, with Whittle's jet providing thrust, and though the flight lasted only 17 minutes, it proved the concept was viable. Ned wasn't at Cranwell to see it. He was back at Power Jets manufacturing the blades for the next generation of engines, but Whittle made sure Ned received a telegram describing the flight. The message was simple, but meant everything. "We flew. Your blades held. History made. Thank you, Frank." The war would continue for 4 more years, and the jet engine technology would evolve far beyond those early prototypes. Ned would continue working at Power Jets through the war and beyond, eventually becoming a supervisor himself, training a new generation of machinists in both the technical skills and the philosophical approach that had made him successful. He would see jet engines transform from experimental oddities to the dominant form of aircraft propulsion, revolutionizing both military and civilian aviation. But for Ned, the most important moment would always be that night in his garden shed, carefully filing a rejected turbine blade by lamplight while Margaret slept, choosing to see possibility where everyone else saw only scrap. That choice, repeated night after night for months, had been his contribution to history. Not the formal education he'd never received, not the expensive equipment he'd never had access to, not the recognition he'd never sought, but simply the stubborn belief that with enough care and effort, worthless things could become valuable. Years later, when journalists would occasionally find their way to Ned's small house in Lutterworth, wanting to write stories about the man who helped build Britain's first jet engine from scrapyard salvage, he would deflect their questions. He'd tell them to talk to Frank Whittle, who had the vision to imagine jet propulsion when everyone said it was impossible. He'd tell them to talk to the metallurgists and engineers who turned that vision into reality through brilliant technical work. He'd tell them to talk to the test pilots who risked their lives flying untested aircraft powered by experimental engines. But if they pressed him, if they insisted on knowing what he thought his contribution had been, Ned would walk them out to his garden shed, which he still maintained even though he no longer needed to work there. He'd show them his old workbench, the vise that still held metal shavings from 1940, the files worn smooth from hundreds of hours of use. And he'd tell them that the lesson wasn't really about jet engines or turbine blades. The lesson was about how you looked at the world. Most people, Ned would explain, saw only what things were. This blade is cracked, therefore it's worthless. This metal is damaged, therefore it's scrap. This person has no formal training, therefore they have nothing to contribute. But a few people, a very few, could see what things might become with the right application of effort and care. That crack could be ground out. That damage could be annealed away. That person could develop skills through dedication that rivaled formal education. The difference between worthless and valuable, Ned believed, was often just a matter of someone being willing to invest the work to reveal the value that was always there, hidden beneath surface imperfections. It was true of metal, and it was true of people. Anne had seen it in him when they married, seeing past his lack of prospects to the dedication and skill he possessed. Frank Whittle had seen it in those reconditioned blades, seeing past their non-standard dimensions to the craftsmanship they represented. And Ned had tried to see it in everything and everyone he encountered, believing that with patience and care, worthless things could become extraordinary. That philosophy guided him through the rest of his life. When Power Jets eventually evolved into other companies and projects, Ned continued working in precision manufacturing, always taking on the difficult jobs others avoided, always finding ways to salvage what seemed unsalvageable. He mentored dozens of young machinists over the years, passing on not just technical skills, but that fundamental belief in possibility. He told them about those long nights in his shed, filing scrap metal while his daughter slept, never knowing if the work would amount to anything, doing it anyway because the work itself mattered. Margaret grew up watching her father contribute to the jet age, and she absorbed his lessons about persistence and craftsmanship. She would eventually become an engineer herself, one of the first women to graduate from Cambridge with a degree in mechanical engineering, and she would credit her father's example for teaching her that formal credentials mattered less than the quality of one's work and the depth of one's dedication. The original blades, the 23 pieces that Ned had reconditioned in his garden shed during that winter of 1939 and 1940, eventually found their way to various museums as the historical significance of Whittle's work became recognized. One blade remained in the Science Museum in London, displayed alongside the prototype engine it had helped power, with a small placard explaining how a widowed machinist had salvaged it from a scrapyard and hand-filed it to precision in his spare time. Thousands of visitors walked past it each year, most barely pausing to read the placard, not understanding that this unprepossessing piece of metal represented something profound about human ingenuity and determination. Ned retired in 1968 after 28 years at what had begun as Power Jets and evolved through several corporate incarnations. His retirement party was attended by dozens of colleagues, several of whom had worked with him since the early days of the jet engine project. Frank Whittle, now Sir Frank and celebrated worldwide as the inventor of the jet engine, sent a letter that was read aloud. In it, Whittle wrote that while he had conceived the theoretical basis for jet propulsion, it was men like Ned Clarke who had made the theory into reality. Men who understood that the gap between concept and execution was bridged not by brilliant insights, but by patient, meticulous, unglamorous work performed by skilled hands. Whittle noted that aviation history remembered the dramatic moments, the first flights and speed records and technological breakthroughs, but those moments were only possible because of thousands of hours of quiet work performed by people who never sought recognition. Ned Clarke represented the best of that tradition, Whittle wrote, and the jet age owed as much to his dedication as to any engineering calculation or scientific principle. Ned lived quietly in retirement, still working in his garden shed on various projects, still unable to throw away anything metal that might be salvageable. He maintained his house and helped Margaret raise his grandchildren, passing on to another generation the skills and values that had shaped his life. He followed with interest the continued evolution of jet technology, watching as the engines became more powerful and efficient, as jet travel became commonplace and transformed global society. In 1973, on the occasion of the 40th anniversary of Whittle's first patent for jet propulsion, the BBC produced a documentary about the development of the jet engine. They tracked down Ned and asked if they could film him in his shed, demonstrating the techniques he had used to recondition those original turbine blades. Ned agreed, though he felt uncomfortable with the attention. The resulting footage showed an elderly man with gnarled, scarred hands carefully filing a piece of metal, his movements still precise despite his age, explaining in his quiet Midlands accent how you could feel imperfections in metal that instruments might miss, how patience was more valuable than speed, how nothing was truly worthless if you cared enough to save it. The documentary aired to modest viewership, and Ned received a few letters from people who had been moved by his story. He answered each one personally, thanking them for their kind words, but always redirecting credit to Whittle and the other engineers who had done the truly difficult intellectual work. He was just a machinist, he wrote, who happened to be in the right place with the right skills at the right moment in history. But those who knew him well understood that description didn't capture the full truth. Ned Clarke had been more than a machinist with good timing. He had been someone who refused to accept the world's judgment about what was possible or impossible, valuable or worthless. He had looked at rejected scrap metal and seen potential. He had invested hundreds of hours of unpaid labor into that potential, driven not by certainty of reward, but by faith that the work itself was meaningful. And when his quiet efforts contributed to a technological revolution that changed human history, he had accepted neither excessive credit nor false modesty, maintaining instead the same steady focus on craft and quality that had defined his entire life. Edward Clarke died in 1979, at the age of 72, in the same terraced house in Lutterworth, where he had raised Margaret and reconditioned those turbine blades 4 decades earlier. His funeral was attended by family, friends, former colleagues, and several engineers from the aerospace industry who wanted to pay respects to a man whose contribution to their field was often overlooked. Margaret gave a eulogy that focused not on her father's role in developing the jet engine, but on what he had taught her about approaching life. He had shown her, she said, that excellence was not about recognition or reward, but about maintaining standards of craftsmanship and care regardless of external circumstances. He had taught her to see value where others saw none, to invest effort where others saw no point, to persist when others gave up. After Ned's death, Margaret donated his tools and his collection of salvaged materials to a technical school in Leicester, along with a scholarship fund for students studying precision manufacturing. The scholarship was modest but perpetual, ensuring that each year at least one student would receive support to develop the kinds of skills her father had mastered. The scholarship carried one unusual requirement, though. Recipients had to spend at least 20 hours per semester working with salvaged or rejected materials, learning to see potential in imperfection, learning that worthless was often just a failure of imagination. In the decades since Ned's death, the jet engine has continued to evolve, becoming more efficient, more powerful, and more reliable. Modern turbine blades are manufactured using techniques Ned could never have imagined, created from materials that didn't exist during his lifetime, produced by computer-controlled machines that achieve tolerances his hand tools could never match. The entire manufacturing process has been revolutionized multiple times over, but the fundamental principle remains unchanged. Jet engines work because precisely manufactured blades can withstand extreme conditions while maintaining their aerodynamic properties. The difference between a functional blade and a failure is measured in tiny fractions of an inch, in the quality of materials and craftsmanship, in the care taken during manufacturing. Every modern jet engine, powering everything from military fighters to massive commercial airliners, is a descendant of those early prototypes that Ned Clarke helped build. Every blade in every engine represents the same principle he demonstrated in his garden shed, that precision, patience, and dedication can transform raw materials into components that perform tasks which seem nearly magical. The small placard in the Science Museum has been updated several times over the years, as historians have learned more about the development of the jet engine. The latest version includes a photograph of Ned in his later years, standing beside his workbench in his garden shed, holding one of the reconditioned turbine blades. His expression in the photograph is characteristically modest, almost embarrassed, but his hands hold the blade with unmistakable pride and care. The placard explains that this ordinary machinist had extraordinary skills, and that his willingness to see value in what others discarded contributed to one of the 20th century's most important technological advances. But perhaps the truest memorial to Edward Clarke is not found in museums or history books. It is found in the countless machinists, engineers, and craftspeople who continue to approach their work with the same dedication to quality he exemplified. It is found in those who refuse to accept that anything is truly worthless, who believe that with sufficient effort and care, rejected materials can become valuable, discarded ideas can become innovations, and overlooked people can make essential contributions to human progress. The Jet Age began not with a dramatic moment of inspiration, but with a widowed father filing scrap metal by lamplight, investing his evenings into work that might never amount to anything, driven by nothing more than a stubborn belief that worthless things could become valuable if someone cared enough to try. That quiet persistence, replicated across thousands of contributors over decades of development, transformed how humans travel and reshaped global society. And at the foundation of that transformation was a simple truth that Ned Clarke understood instinctively, that the measure of something's value is not found in its current state, but in what it might become with the application of skill, care, and dedication. History celebrates the visionaries who conceive revolutionary ideas, and rightly so. Frank Whittle's theoretical insights were essential to the development of jet propulsion. But ideas alone change nothing. They require the Edward Clarkes of the world, the skilled workers who can take a concept and make it real through patient, meticulous effort, who can look at a rejected turbine blade and see not scrap metal, but potential, who can spend hundreds of hours on work that might fail, but do it anyway, because the effort itself has value. In the end, the story of how one machinist's worthless scrap built the first jet engine prototype is not really about jet engines at all. It is about how progress happens, not through lone geniuses working in isolation, but through the collaborative efforts of many people, some famous and some anonymous, all contributing their particular skills and perspectives to solve problems that seem impossible. It is about how the most valuable contributions often come from unexpected sources, from people without formal credentials or recognition, whose only advantages are dedication and craftsmanship. It is about how what the world discards as worthless might actually contain extraordinary value, if only someone has the vision to see it and the persistence to reveal it. And it is about a father who wanted to give his daughter a better life, who found a way to turn scrap metal into security, who demonstrated through his actions that worthwhile things are built not through dramatic gestures, but through the accumulation of small, careful efforts performed with unwavering attention to quality. In his garden shed in Lutterworth, working by lamplight while his daughter slept, Edward Clarke filed rejected turbine blades and quietly changed the world.